So today we're going to talk about methods, kind of corresponding to the idea of functions in your C language and your Python language, except a method is something that's attached to a class, whereas a function is considered a standalone, not attached to a class. And since in C# absolutely everything is a class, then there are no functions, everything is a method. So it's a bit of code. It has a name. It can have an optional parameter list. It can have a return value. If it doesn't have a return value, you declare it as void. And it's a body of code that you invoke with a single name. And I'm sure that by now you've had a programming class or experience with the idea of functions or methods, body of code that's attached to a name. So I don't think that we're going to have to linger too long on this idea, but C# throws us some interesting things, particularly in how data is passed in, arguments going into the parameters. Considerably more sophisticated than what you can do with Java. And I wouldn't mind if Java some days appropriated some of the concepts. So learn about methods and implementation hiding, write methods with no parameters, no return value, write methods that require a single argument. Yeah. So, what is a method? It's a series of statements that perform a task. It has a name. Using the method is called invoking or calling the method. You write a method called double me. You invoke that method. You call that method. So, main. Main is a method. We always create a main method when we create our new C#. This is saying that it's a void method, meaning it doesn't return any data. It doesn't return any values. Static means that it is a class method rather than an instance method. An instance method is one that's not declared with a static keyword. And to use it, you have to create an instance of the class. A class method is one that you do declare with a static keyword, meaning you do not declare an instance before you call it. And here we see a method called writeLine. So writeLine is a method. Looks like a function, doesn't it? It's not attached to any class, but it is. If you come up here and look, we're doing the using, the namespace. This is a class right here, system.console. And system.console, console is a class. One of its methods is writeLine. WriteLine is a static member of the class, meaning it's a class method, not an instance method, meaning we don't have to have an instance of the console class in order to call it. We don't have to say console C is equal to new console before we can call writeLine on it. And the same is true for readLine. So, implementation hiding. An important principle of object-oriented programming is the idea that you just provide the name of the methods. You give them the interface, and when I say them, the programmer, whether the programmer is you or another team member or somebody in the far future, an interface to interact with the data. So the program, or the programmer, does not need to know how the method works. I don't know how to calculate the square root. I don't know how to query the keyboard and pull stuff out of the buffer in order to do a read line. So the method that uses another is a client of that method. Now if you're taking another class, you'll keep hearing the word driver. I like the word client better. So here, the main method is a client of the console class. So it's a client of the writeLine method. Methods exist in a black box. It's a virtual device that you can use without knowing how it works internally. You don't need to know how to calculate a square root or how to display information on a screen. The black box will consist of data, and it will consist upon the methods that act upon that data or use that data. So the main reasons to create a method: the code will remain short and easy to follow, and the method is easily reusable. Fights code bloat, which is when you have unnecessarily long or repetitive statements. If you find yourself copying and pasting a loop, or 30 or 40 lines of code over and over and over, you should have made that a method, and you should revise your program to make it a method. So when you create a method, you declare it. Method declaration, also known as a method header and a method definition, because we always have to have more than one name for the same concept. I'm going to call it a method declaration. I might slip and call it a definition. You give it a name, you give it a curly brace, you give it a body of code, you give it a closing curly brace, and they're leaving out two more things. Well, they've left off the name of late, and they've left off the return type. Return type, name. They've left off quite a few things, but they've left off the parentheses with the optional parameter list in it. I guess we'll see those in a bit. So, in this language, when you define a method, optional declared accessibility, the optional static modifier, this is like if it's public or private, which we'll talk about. This is whether it's static or not, which indicates that it's a class member or an instance member. The return type, whether it returns nothing, which is void, or an int or a double or a string or whatever. Your opening parentheses, your optional list of method parameters, and your closing parentheses. So you could have public, static, void, main, like that. And I forget whether main is capitalized or not. Yes, it is. They don't declare main as public, so we could leave that off. All right, so like that. That's our method declaration, and we would put a body of code in the method. Right line, hello. This is leaving off the optional declared accessibility, and we haven't put in a list of parameters. Let's give ourselves another one. This is going to be an instance member, so it's not going to have the static keyword. Public int double me, and it's going to take another int called x, and the body of the code is to calculate double the value of x. Int y is equal to 2 times x, return y. Now if you declare your method as void, it does not have a return statement, although it won't break it if you add one. Some compilers will flag that with a warning. You don't need a return statement. I think that's obnoxious, because there's nothing wrong with having a return statement, an explicit one. But it's implied when you hit the closing brace of your method's body, then it does a return anyways. Here we calculate the value we stored in y, and then we return that y. That y is returned as an int, so that the client code down here in main somewhere, blah blah blah, could call double me like that and pass in 100, and it could store its result in a variable, int rv for return value, like that. Now there's a little bit of a problem here, is that we don't have a class surrounding this stuff. Everything is part of a class. I'm just kind of speaking, in generic terms. And if this was all part of the same class, like if we put this here, then since this method is static, this would have to be static as well. We'll get more into that later. But in general, that's how you declare a method. Accessibility, return type, variable name, parameter list, which is optional and might not have any parameters. And if you're going to make it a class method, you stick the word static in there.
I have a quick question.
Yeah.
About okay, our governing method, how you store our value in y, and then you return y. Is there a reason that you do that? I mean, because sometimes I see people just do return. It would be just return 2 times x.
Right. Is there a reason that I did it this way as opposed to just saying 2 times x? Not really, except I thought it made it a more interesting body to have 2 lines of code rather than 1. The reason I tend to create a value and then return it like that is because if I wanted to, I could print the value out before I returned it. You know, I calculate the value, then I have the value so that if I'm stepping through it with a debugger, I can hover my cursor over and see what Y was before it got returned, or I can print it out in a debug message. I, in general, like to calculate my value and then return it, rather than just return the calculation right then and there. And in general, if you have a method body that's only one line long, you didn't need to make it a method to begin with. Yeah.
Unless it's an access modifier. Or an access, not an access method. Access method.
Yeah.
Returning this stack.
Right, yeah. Setters and getters will be just one line of code. That's a very, very good point. So I'm going to go ahead and make this actually look like what we would see as we developed. So all of this would be enclosed in a class, right? Blah, blah, you know, blah, blah. This is one of those languages where the order of declaration is not important. It's not like double me had to be declared above main. And you don't have to create a header file in order to declare your class. Unlike Mr. C#. So here's our, don't think we need to spend too long on this. It's what we've been talking about. Access a modifier, if it's omitted, it's private, which is a little bit different than Java, where if you omit it, it's got a access modifier of package, which is almost public. The static modifier, the return type, or void if it returns nothing, the name, the parameter list, this one doesn't take any arguments. And what does it do? It prints, welcome, have fun, enjoy the program. And then kind of that invisible return statement before the closing brace. So an introduction to accessibility. Limits how the other methods can use your methods. If it's public, then other classes can call that method. If it's private, only this class can call that method. If I go into here and I make double me private, then no other class in the project can access it. Only methods within the my class can call that method. Same goes for data. You know, if I declare a variable, I can make it a public variable, in which case any other class can go in and modify its values. And variables, by the way, can also be declared as static or not. And if I declare it as, did I reverse that? Public means that the other classes can change it. Private means that only this class can change it. So private access is established by including a private modifier or by omittifying any altogether. Limits a method access to the class that contains the method. So when you use a method's complete name, including its class, you use its fully qualified name, console.writeLine. But that's for a class method. If this was an instance method, this would instead be the name of an object, you know, x.writeLine, whatever. But writeLine is declared as static, so you invoke it by preceding the dot with the name of the class. So declared accessibilities. You'll see that there's actually several different layers, not just public and private. And our categories. Can methods contained in the same class access this method? Can derived classes access this method? Can assemblies or projects that contain the class access this method? And can any class access this method? Okay, so for the can any class access this method, there's only one type that does that. That's the public. As far as can methods contained in the same class call it? Yeah, no matter what, methods in the same class can call it. If you're using inheritance, can derived classes access it? If it's declared as public, protected internal, or protected, yeah, your inherited, your subclasses can call it. Then there's internal. Can assemblies or projects that contain this class access this method? Which internal is the same as private, except it means that other projects can access it. However, child classes cannot. Honestly, I never used internal. And then can any class access this method? We already talked about that. Public classes, everybody can use it. Wait a minute. This is wrong. Oh, no, sorry. So public, absolutely everybody can access it. Private, only other things within the same class can access it. Protected means that the class and any of its subclasses can access it. And then there's the other ones, the protected internal and the internal, which are kind of shades between those. You can declare a method to be static or non-static. It'd be kind of cool if they had a non-static method. Static as a keyword predates object-oriented programming, and it meant something different back in the C language than it does now. I'd like it if we had a class keyword and we had an instance keyword. And we use that rather than the word static, and we use that rather than leaving off the word static, right? Because we always call them class members, or we call them instance members. Why not have keywords that match? But we don't. Methods are non-static by default, just like methods are private by default. So if we went in and we declared a method like this, void test, like that, and it did something, whatever it was supposed to do. It doesn't have an access modifier, so it's private. It doesn't have a accessibility static, modifier, so it defaults to being non-static. So if it's static, it can be called without referring to an object. Instead, you refer to the class. It cannot call non-static methods in the same class. I always forget that term. In the same class. A non-static method. That's the default. You have to create an object before you can use it externally. The client code has to create an object before it can call the method. And non-static methods can call static methods in the same class. Alright, so if I was going to rewrite this a little bit, the client code can call a static method without referring to an object. The client code for a static method can only call it in conjunction with an object. That'll make more sense as soon as we make other objects other than the main one, which has been created by default every time we make a new project. Return types. Every method has a return type, unless it doesn't return anything, in which it still has a return type of void. Now, you Python guys may be used to the idea that if you declare something without a return type, there's actually kind of a hidden return value of none. No such thing in this language. A return type is more succinctly known as the method's type. Okay, I usually just call it return type myself. The method name must be a legal C# identifier, so it has to follow the rules of C#. Identifiers, can't have spaces in it, that kind of thing. The parameter to the variable is the variable that holds data passed to the method as an argument when it is called. Like the WriteLine method takes data to be displayed on the screen, so it has a parameter declared in it. The parentheses that follows the method name in its header in this declaration could hold one parameter or multiple parameters separated by commas. The contents are known as the parameter list. So here is our parameter list for the double me method. We could make another method called add me private static int add me, which takes two values. Int result is equal to x plus y. Return the result. Like that. So when our client code, in this case main, wants to invoke it, it has to pass in two arguments. So when we see this, we know what's going to happen. This is the invocation. It's where we call it. It jumps up here. It runs this method. What? I actually wanted to do add me. Yeah, thank you. So add me jumps up here. These two arguments get copied into these two values. Then some code executes. It returns a result. That result gets assigned into that variable for whatever purposes. So the return result would be 30. Placing a method in the class. Methods have to be part of a class. The show message. You can put methods above main. You can put the methods below main. The order of the methods is not important in this language, unlike the order in which you declare functions in some languages like Python and C++. So you can put them in any order, so you just get to pick. Do you want to put main up at the top, where it's easy to spot? Do you want to put it at the bottom? It's up to you. But you can't put it in two places, because then you would have two methods. So here they're showing putting a show welcome message method, and they tucked it away underneath main. And they declared it as static so that it could be invoked by this static method main. They declared it as void because it doesn't return a value. Declaring variables and constants in a method. You can declare variables inside the body of that method. You can declare constants, and that makes them local to that method. Their scope is defined by the boundaries of the method. They're defined by the body in which they are declared. So you see our y variable here. It is only valid between these two braces. Yeah, it gets returned, but that's just a value getting returned. You know, if you come down here and you try to print out y, you know, console.writeLine, try to print out y, that's not going to work because this variable was local to the body of this method within those braces, so it's inaccessible here. It's out of scope. What if you wanted it to be in scope? You could make it a class member. You can have class variables, and class variables can be accessed by multiple methods within the same class. And we'll get there. They go out of scope when the method is exited. They are not accessible outside of that method, except when passed as parameters to other methods. Yeah, that's a good point. Hadn't quite thought about that. If you declare you know our code try parse, you know, bool okay is equal to integer dot try parse, and you pass in a string, and you pass in a value, a parameter like that, an argument like that. Here we have a local variable, but the variable itself is getting passed to try parse, so that the try parse method can change that value. And that happens by the magic of that keyword. We'll talk about that later. You could replace that with the word in or out. What's going on there, for you guys who already know Java, is that C# by default is doing pass by value, pass by copy, so it only passes a copy of the value. You know, this X here is just a copy of whatever was passed in. But if you want to pass in by reference, so that the variable, this method actually has access to that variable itself, then you can declare it such, something Java does not support. So here we declare a variable int a is equal to 12.
Mr. Thompson.
Yes, sir.
When you get finished, could you come see me? I need to ask you a question. That's
Sure,
all. Just
sure,
need to
sure.
ask you a question. Whenever you get
Will
finished.
do. Okay. So a is equal to 12. That's a local variable. Down here, we will not be able to access that 12 in here because it wasn't passed in. This is the method. This is the client code. They declare another a, but that one's local to that block. So just because this block creates a variable called a and sets the value to 354 doesn't change the value of that a. These are completely different memory spaces. They are declared completely within their own blocks of code. Methods that require a single argument. The parameter list needs a type and a name for the parameter. We did that in our example right here. We declared a parameter called x. It has a type. When we invoke it, we pass a value into it. The value could either be a primitive value like 100, a literal, or it could be, another variable. I declare, int Nito is equal to 100, and then we could pass the value of Nito into here. And when that happens, this value is passed in as an argument, which gets copied into that parameter right there to be used. So it'd function the same way, right? Nito is equal to 100, so we're going to copy the value 100 into x. We're going to multiply it by 2, get 200, and we're going to return that, which will get copied across the assignment operator into that variable. So RV after that executes would be 200. So this textbook, I'd forgotten this, doesn't use the term arguments the way that our other Java textbooks do. They felt like calling them actual parameters. So you Java guys, just remember that where you were using the term arguments, you could use the term actual parameters. So up here, what is our formal parameter? X is our formal parameter. Down here, Nito, and I used a wrong style comment. Nito is our actual parameter, also known as an argument. So display sales tax accepts as a formal parameter an amount called sale amount, takes it, multiplies it by a value, prints it out. Since it's not returning anything, it's declared as void. It's declared as static so that the main method, which is also static, can access it. And it's declared as private because no other code needs to be calling our display sales tax. I don't know, I'm not usually so picky about that. As long as this, yeah, I'll just leave it at that. You can also write a method that requires multiple arguments. Yeah, check this out. They're still using the term arguments. Okay, so I'm not going to use the term actual parameters very often. I'll just accept it when the slides show it. Here we have two formal parameters, x and y, which are passed to the add_me method. And so when we invoke it, we're passing in two arguments that fill in those formal parameters. And you could create something that had 20 formal parameters. Pass in 20 arguments. Writing a method that returns a value. We've seen this, we've already demonstrated. You're not required to use a return value, even if it makes one. Private, static, int, ignore me. Who cares what it returns? Return 32. If you call ignore me, you could store its return value in a variable. You could say int I for ignored, is equal to ignore me. You could do something with that, or you could just say ignore me, in which case that 32 is just, you know, lost in the wind. It's not stored anywhere. Are you going to do that? Well, I don't know. Like the C language, all the built-in functions tend to return values. So even functions like printing return a value, which is really pretty strange. And then everybody ignores them, right? You know, because you just assume that the print statement's going to work. But in general, if you declare something as returning a value, it's because you probably are conveying useful information back. So I would say that you're usually going to store it in a variable, and then you're usually going to use it. If you were going to ignore it, why not just declare it as void? So our calculate pay, which multiplies hours by rate, has two formal parameters, hours and rate. This declares a local variable called gross, which is hours times rate, and then it returns gross, so that whoever calls calc pay can hopefully, you know, store that return variable in a result, or at least print it out, you know. A return value can be stored in a variable or used directly. What does used directly mean? You could pass it directly into another method, like a print statement, or as a argument for another method that you write. Or you can store it in a variable for later use. Nested method calls. You can put method calls inside other method calls. Let's write a little chain of methods. And I know I'm not actually I'll type this stuff in, but this is just basic lecture type stuff. I don't think we need to demonstrate it in the framework of a larger code. So I'm going to declare a couple of functions. Static x1, which takes a variable called a. And what does it do? I don't know. Static void x1, I don't even know what it does. It just prints out that variable. Console.writeLine a, right? And then you declare another one, static void x2, which accepts a variable. I don't know what it's going to do. Maybe it's just going to print it out. Console.write. Now we have two functions now that do the same thing. Okay, how about a times 2? It prints out double the value. And then we create one more, which is going to print out triple the value. Static void x3 accepts a parameter. I put a colon there, which is a horrible syntax error. Semicolon. Excuse my rattling keyboard, guys. Alrighty, take that colon out. Alright, so x3 is going to print out 3 times that value, alright? I'm just going to copy and paste because I'm not expecting you to type along. Alrighty, here's what you could do. You could say, I'm just going to stick this up at the top of main. We have x1, x2, and x3. You could say int my value is equal to int1, int2, x1, x2, x3, like that. Now that's dumb. I declared these as void, and to properly demonstrate this, like that. Yeah, that would not work because I declared these as void. Let's revise these a little bit. Sorry about that. I'm going to make them ints. That one returns a. This is an int that returns 2 times a. So x2 returns 2 times a. x3 returns 3 times a. So here we go. When we invoke x3, we're going to pass in 100. What's going to happen? We call the innermost parentheses, right? Just like when you're doing mathematical calculations and PEMDAS and whatever, you know, parentheses get done first. This is the innermost parentheses, so we're going to invoke x3, passing in 100. It prints out 300 and it returns a 300. Okay, so now we have a value of 300, which we're passing in as an argument to the x2 function. So we call x2, passing in 200. It calculates double that and returns it, which is 400. So that value of 400 gets passed into the x1 function, which gets out here, prints it, doesn't multiply by anything. And so by the time we're done, should that not have been 600? Feels like I flubbed that.
100 times
Yeah.
3.
x3, that's 100 times 3, so we have 300. Then we pass it into x2, which doubles it, and so that's 600. And then we pass it into x1, which doesn't do anything. So that by the time we get done with that, my val is equal to 600. So we use the return value of that method as an argument for that method, and we use the return value of that one into that. More simply, you know, if you're going to write out something, console.write, you know, you could do x2 300, right? That calls this function, comes up here, returns twice that, so we have 200, and we write that out. So the return value of that method is passed in as an argument to that method. I may have made that example a little bit too complex. This one hopefully hammers it in.
So if you say you have a void method and you store that in a variable,
Can't.
you can't store
Be a
it.
syntax error. Right. Yeah, you can't store a return value of void into a variable. There is no variable type called void. You can't say void x and then x is equal to, you know, my method name. All right, Adrian's trying this out, so I'm going to pause it, see if that's true.
What does it do?
All right, so this is somewhat silly, but your return types can be such things as int or double, but they could also be bool. I don't know why we might question whether bool would be different than anything else. You know, still a return type. We'll do a return type of bool, and then we'll probably be done with it. Let's do static bool is even. We're going to pass in an integer x. We're going to determine if it's even. So bool even is equal to, and we know how to check to see if something is even. You modulus it by 2, and if that result is 0, then it's even. So down in main, you could do this. If is even 100, you could write line, yeah, it's even. Yes, it's even. Like that. Do you have to? I mean, you could also store that in a flag beforehand, you know. You could say bool even is equal to that function, that method call, and then you could do if even like that. Either way, that works. So yes, bool is a return type, just like double and int and string. All right, that's about enough, guys. Into the Dropbox, just upload a note saying that you watched the lecture, and you're done with today's lecture. Go ahead and read the rest of Chapter 7. We're about halfway through it. Chapter 8 is on more advanced method topics. And then after that, we're going to get to the idea of classes. I keep mentioning classes, so it'll be about time that we get to them. Any other questions?